A while ago I made a video about temperate ice giants, one of my favorite types of planet. A temperate ice giant is exactly what it sounds like, an ice giant where temperatures are similar to Earth. This makes an environment that is simultaneously extremely alien with no solid surface and harsh weather, but also unexpectedly Earth-like. A lot of ice giants have surface gravity similar to Earth, and that, combined with habitable temperatures and the fact they have water rain, it's probably the most Earth-like environment you could possibly get on a planet that isn't rocky. There are probably many temperate ice giants in the universe that you wouldn't even need a spacesuit to be on, just a breathing mask. Other than the air isn't breathable, it could be fairly comfortable. But ice giants have bigger cousins, temperate gas giants. These are large gas giants in the habitable zones of their stars where temperatures are right for liquid water to exist. I've covered several of them on my channel already, especially in my Grand Tour series, where a few systems I've covered have a temperate ice or gas giant. Upsilon Andromedae has Majradi, a planet so large it borders on being a brown dwarf. Mu Ari has Quixote, with a very similar orbit to Mars around a star larger than the Sun. I've also mentioned planets like the temperate gas giants Melquiades and Perwana in other videos. But we know of dozens of temperate gas giants, and they're all different, both from each other and compared to ice giants. There's likely a much wider range of sizes temperate gas giants can be in comparison to ice giants, for example, ranging from only marginally bigger than Neptune to several times larger than Jupiter. There are a ton of different gas giants in the habitable zone, and it's very difficult to make generalizations about all of them that will be true for all of them. So for this video, I'll be talking about a few specific temperate gas giants I find interesting, to hopefully get a glimpse into the range of environments these planets can have. But first, when people talk about gas giants in the habitable zones of their stars, the topic of habitable moons usually comes up. I've talked about this a lot, but to put it simply, the bigger a planet is, the more likely it is to host a large moon, and the larger the moon is, the more likely it is to be interesting. Bigger planets form with more material around them, meaning they have more material to form moons. This either results in a greater number of small moons or a smaller number of larger moons. This is easily seen in our solar system. Jupiter, the biggest planet, has 4 large spherical moons, the biggest of which is bigger than Mercury in radius and only a few hundred kilometers smaller than Mars. Saturn, 3 times less massive than Jupiter, only has 1 moon of this size but has several smaller ones. Uranus's largest moons are only as big as Saturn's smallest spherical ones. However, this isn't always the case. Earth has a moon that rivals Jupiter's moons in size. Neptune has a captured dwarf planet. But even though there are exceptions, the general rule is the larger the planet, the larger the moons. This will likely be true for temperate gas giants as well. The biggest one will have higher chances of hosting large moons. But then again, the larger the gas giant, the stronger the magnetic field and tidal forces, which could be a problem. Again, looking at our solar system, Jupiter's magnetic field and radiation belts are a death sentence for its inner moons. Io is the most volcanically active object in the solar system. If it weren't orbiting Jupiter and somehow kept the same level of activity, it would have an extremely thick atmosphere. But because it sits directly within one of Jupiter's radiation belts, the atmosphere is stripped away faster than it can form, leaving Io airless. Radiation levels on Io are so high that even with shielding, you'd be dead in a matter of hours. The same is also true of Europa and Ganymede to a much lesser extent. On Europa, you'd be dead in days, and Ganymede is likely far enough away for radiation to only be a problem on the timescales of years. Callisto is far enough away to be outside the radiation belts, but also far enough away that tidal forces are so weak it doesn't have any geologic activity, leaving it airless anyway. But moons with atmospheres around gas giants can definitely exist. Titan has a very thick one, though that's mostly because it's extremely cold. Colder objects have an easier time holding on to atmospheres, because the air on them is moving slower, making it harder to speed up to the point where it would escape. Triton has a thin atmosphere as well, though one thick enough to host clouds. So, habitable moons around temperate gas giants could very well exist, but they have to be in extremely delicate balance. The gas giant has to be big enough to have enough material to form a large moon, or it could just get lucky like Earth and Neptune did. That moon then has to be big enough to hold on to its atmosphere with the higher temperatures of the habitable zone. Then it has to be close enough to the gas giant or other moons to have geologic activity, but not too close where the radiation belts would strip it away. And even if everything goes perfectly and you get a large moon with geologic activity and an atmosphere, it could still just as easily become like Venus or Mars instead of like Earth. Habitable moons are probably extremely rare, but definitely possible. But remember, there are a lot of environments habitable zone objects can have. If you assume an optimistic habitable zone, the solar system has 4 objects inside it: Venus, Earth, the Moon, and Mars. All 4 of these worlds have wildly different environments, and there's no reason to think the same wouldn't be true of moons. A moon being planet-sized and in the habitable zone does not automatically mean it has a chance of being habitable. But anyway, they're also probably more likely around larger gas giants. Which is why of all the temperate gas giants I'm aware of, I think Majradi is the most likely to host a habitable moon. I talk about Majradi in a few videos, like a grand tour of Upsilon Andromedae, so I'll keep this section short. Upsilon Andromedae D, which was officially named Majradi in 2015, is about 10 times the mass of Jupiter and in the habitable zone of Tidowin, a star slightly bigger than the Sun. That large mass, combined with a large star, means Majradi could very well have formed with more than enough material to host moons the size of Mars or Earth, though this is not known for certain. Whether that mass is split between several smaller moons or one big one, for example, is another problem too. We don't currently know of any moons around any exoplanet, let alone habitable ones around Majradi. But Majradi, being so large, has probably the best chance of any temperate gas giant I'm aware of, though there may be other planets out there with better chances that I've missed. But this video is going to be about temperate gas giants themselves, not just their moons. Majradi is so large it's bordering on a brown dwarf in size, meaning it likely has a ton of internal heat and very high surface gravity. Despite being so massive, it's almost exactly the same size as Jupiter in radius, meaning it's very dense, and so has very high surface gravity and temperature. You wouldn't be able to stand if you were on Majradi due to the high gravity, which is likely only a bit less than the surface gravity of the Sun. It would also get very hot very fast as you descended into the planet. This is true of most temperate gas giants, though most to a much lesser extent than Majradi. They have surface gravities much higher than Earth, making them less Earth-like than temperate ice giants. I should also quickly clarify what surface gravity means in this case, because gas giants don't have surfaces. From what I can tell, surface gravity in terms of gas or ice giants is calculated from the point where the density of their atmosphere is the same as the surface on Earth. So when you say Jupiter's surface gravity is about 25 meters per second squared, that's being calculated from the point inside Jupiter's atmosphere where there are similar pressures to Earth at sea level. Anyways, Majradi's orbit isn't very circular. It has an orbital eccentricity of 0.3, meaning its orbit is more of an oval shape than a circle. For some reason, of the temperate gas giants I researched for this video, this seems to be pretty common. Quixote, the planet I talk about in Grand Tour of Mu Arae, has an eccentricity of 0.12. This is much higher than the orbital eccentricity of Earth, but Mercury's eccentricity does get up to this level. And the next temperate gas giant I'll talk about, Tryob, has an eccentricity of 0.34. HD 153950b, officially named Tryob, is about 2.7 times more massive than Jupiter at minimum, and orbits an F-type star called Rapido at about 1.3 AU, 30% further than Earth orbits the Sun. It takes about 500 days to make a full orbit of its star, but because of its elliptical orbit, it has very extreme seasons. While Tryob's temperature has not been directly measured, it likely varies from 2 to 102 degrees Celsius, or 35 to 215 Fahrenheit. So depending on what point Tryob is on at its orbit, it could either be cool enough to allow for liquid water to exist on it, or hot enough to boil it. Like other elliptical gas giants, this could lead to extreme changes of weather during Tryob's year, which is seen very clearly on planets with even more drastic orbital eccentricities, which I'll talk about in later videos. Assuming its minimum mass is accurate, Tryob could easily host moons much larger than Ganymede, but again, we can't say much about its habitability. Though it would be very interesting if Tryob hosted a moon with oceans. When Tryob is at its furthest point from Rapido, the water would be on the verge of freezing over. But when it's at its closest, the oceans will begin boiling away, only to cool off again, repeating the process over and over in a 500-day cycle. Not a particularly habitable environment, but an extremely interesting one, assuming we get lucky and it exists. This is just my own speculation, I'm going off the top of my head here, but I think that if a moon with oceans was in an orbit like this, it could pretty easily enter a runaway greenhouse state. Water vapor is a powerful greenhouse gas, and if for a few weeks or months of every orbit the temperature rises to the boiling point, that's going to release a ton of water vapor into the atmosphere, which may linger even after the moon cools down, making it a steam planet. Unfortunately, we know a lot less about Tryob compared to Majradi, so I can't say much else. But after all this talk of temperate gas giants with elliptical orbits, I started trying to find one with a normal circular orbit, and those do exist. The first one I'll talk about is Melquiades, or HD 93083b. To be honest, I'm mainly only talking about this one because 1, I like its name, and 2, it was one of the first planets I ever talked about on this channel, though that video is several years old at this point and I wouldn't rely on it. Melquiades is about the mass of Saturn, and orbits its small K-type star Macondo at about half the distance Earth orbits the Sun on a 143-day orbit. It still has a decent orbital eccentricity of 0.14, which is between the eccentricities of Mercury and Mars. But what's interesting about Melquiades is a 2007 study suggesting that its L4 and L5 Lagrange points would be stable for long periods of time, which would mean that planets would be able to exist there. Lagrange points are areas where the gravities of two objects cancel out, leading to objects inside them tending to stick around. We call those objects inside these points trojans, and Jupiter is thousands of Trojan asteroids. They're 60 degrees ahead of and behind Jupiter and share its orbit. But planets are much larger than asteroids, and so are likely unstable after short periods of time inside Lagrange points. But there are highly specific cases where they could be stable, and Melquiades is potentially one of them if this study from 19 years ago is correct. And the study found that it should be possible for there to be Earth-sized planets in the Melquiadean Lagrange points. Now, Lagrange points being capable of hosting planets and planets actually being there are two different things. And again, this study is also from 19 years ago, so it could be very out of date by this point. But as far as I'm aware, it hasn't been refuted, though if I'm wrong about that, just correct me in the comments. Melquiades isn't the only planet identified in the study, however, as 6 other temperate gas giants are also potentially capable of hosting Trojan planets. In all of these cases, if a Trojan planet did exist, it would also be in the habitable zone, and so could have a chance of being habitable. Speaking of multiple planets in the habitable zone, that can happen with temperate gas giants as well. Though it's probably decently rare because large planets tend to destabilize other planets nearby. So for 2 or more gas giants to be in the habitable zone, a lot of things have to go right, or the habitable zone just has to be big enough to host them all. Which brings us to HD 34445. This system has a Sun-like star and at least one confirmed planet orbiting around it, the temperate gas giant HD 34445b. But there are 5 other unconfirmed planet candidates in the system, and one of them, HD 34445f, is also in the habitable zone. The 5 additional planets were suggested to exist around 2017, but a 2021 study suggests that planets E, C, and D were false positives caused by stellar activity, F wasn't found at all, and G remains unconfirmed. It's safe to say that currently these are not strong candidates for existing. But if planet F does exist, which doesn't seem very likely, then that would mean that the system hosts not 1 but 2 temperate gas giants close to one another. HD 34445b, the only confirmed planet in the system, is at least 2/3 the mass of Jupiter, and the unconfirmed F is at least 11% Jupiter's mass, about the third the size of Saturn. This would make it more similar to Neptune in size if it exists at all. Studies of the system suggest that if all these planets do exist, they would be stable. So even if Planet B is the only planet confirmed to actually exist, this place shows that systems with more than 1 temperate gas giant can happen. If both these planets exist, it may be a possibility that they have especially small moon systems, as they're separated by less than half an AU. Having giant planets that close will make hosting moons on long, faraway orbits difficult. But anyways, temperate gas giants are definitely a very unique type of planet. Unlike temperate ice giants, many of them have much higher surface gravities and far more chances for habitable moons. They also have a much wider range of potential sizes, with the unconfirmed HD 34445f being at minimum less massive than Saturn, and Majradi being 10 times bigger than Jupiter. A ton of them also have strangely elliptical orbits, leading to drastic seasonal changes. We've discovered dozens of gas giants in the habitable zones of their stars, and will likely only find more as we keep searching. And hopefully we can find out more about the ones we already know of. Thank you for watching. If you enjoyed, check out my other videos about space and space exploration.